Radio, one last video on infrared spectroscopy, number 4, and we've just got a couple of loose ends to tie up. So we haven't done alkenes or haloalkanes. So let's return to the spectra here. You'll notice I've just varied the way I've done my C to H peak. Just one other thing about spectra is that they're not perfect. We give you as good a spectra as we can find, but in the real world these peak sizes really do vary. Where they're found varies slightly, but is pretty consistent. It's not exact, but it's around the same place every time. But the appearance of the peaks can sometimes be quite different. Rightio, so what are we looking for an alkene, a C double bond to C? And to be honest with you, it's unlikely for you to get asked this because there's not as much to analyse, but we're looking for a very weak peak. So this one's, as you can see, not very big. And our, our peak is at 1630 to 1690. And that P gives us our link, our L, to our alkene group, C double bond to C. So just referring you back again, our peak, we need to link it to the structure. We need to analyse and interpret. And at the end, we need to tie it all together. Now, we haven't done a lot of this T yet, and we won't really until we learn our other spectra. Okay, so our alkene will have some kind of C to H peak around 2,850. It could be a big one, could be a small one, mostly big actually. And it will have this weak peak, quite sharp usually, at around 1630 to 1690, which is linked to our C double bond to C. Okay, so haloalkanes. Now we've generally got lots of halogens in our haloalkanes. We can have in class, and when we're looking at haloalkanes, we can have any of these halogens as part of it. But for these spectra, we're going to focus on Cl and Br. We're down in the fingerprint region, and the only time we're going to use the fingerprint region is to identify the CLs and the BRs, and the difference is there's at least one sharp peak for BR and there's at least one sharp peak for CL, and the BRs tend to be slightly more that way and the CLs tend to be slightly more that way. The actual numbers given to you for the BR are 510 to 650, and the numbers given to you for the CL on your resource sheet are 540 to 785. So you're looking for the presence of a couple, 1 to 2 really sharp peaks within those kind of boundaries, and that, along with our C double bond to H, will give us evidence when we analyse and interpret for a haloalkane. And that wraps up infrared spectroscopy. So last reminder, what are we getting out of infrared? We are looking for the presence or absence of functional groups.